What if the most destructive force in the cosmos is also the most creative? We look up at the night sky, a vast and seemingly endless expanse, and we ask the biggest questions. Where did all this come from? How did our universe begin? For decades, we've told a story of a single, explosive moment, the Big Bang, a universe born from an infinitesimally small, hot, dense point. But what if that's only half the story? What if our entire cosmos with its billions of galaxies and countless stars is nestled deep inside something else? Something we've always thought of as an ending. What if we are living inside a black hole? This idea stretches the very fabric of our imagination. It challenges our most fundamental understanding of cosmic birth and death. On one hand, you have the Big Bang, a theory that has served us well, explaining so much of what we observe. It tells a powerful story of expansion, cooling, and the slow, majestic formation of everything we see and are. On the other hand, you have a radical new proposal, one that whispers of a universe before ours, a parent universe, and a cycle of cosmic creation that is far grander and stranger than we ever dared to dream. It's a journey from a single point of origin to a potentially infinite family tree of universes. The question forces us to reconsider the nature of beginnings and endings. We tend to see them as final, as absolute bookends to a story. A star dies in a supernova, its light extinguished. A black hole forms, a point of no return from which nothing, not even light, can escape. We see these as cosmic finales, but the universe has a habit of surprising us. It operates on principles that often defy our everyday intuition. What if the crushing grip of a black hole isn't a dead end? What if it's a cosmic doorway, a celestial womb giving birth to a new space-time, a new universe with its own stars, its own planets, and maybe, just maybe, its own curious inhabitants asking the very same questions? So let us embark on a journey of cosmic exploration. Let's weigh these two epic stories against each other. Is our universe a singular, magnificent accident, a one-time event that burst forth from an unknown state? Or is it a child, one of perhaps countless children born from the collapse of a star in another older, vaster cosmos? The answer isn't just about astronomy, it's about our own origin story. To understand where we might be going, we first have to understand where we think we came from. The prevailing scientific story of our origin is the Big Bang Theory. It's a name that sounds loud and chaotic, but the idea behind it is one of profound elegance. It says that about 13.8 billion years ago, everything in our entire observable universe, every star, every galaxy, every planet, every atom in your body, was compressed into a point of unimaginable heat and density. It was a state smaller than a single atom, a singularity. Then, for reasons we still don't fully understand, it began to expand. This wasn't an explosion in space like a bomb going off. It was an explosion of space itself. Every point in the universe began rushing away from every other point. In the first fractions of a second, the universe inflated at a staggering rate, doubling in size again and again in a cosmic blink. As space expanded, it cooled. The primordial soup of fundamental particles began to clump together. Protons and neutrons formed. Then, after about 380,000 years, the universe cooled enough for electrons to be captured by atomic nuclei, forming the first atoms, mostly hydrogen-helium. At this moment, the universe became transparent, and light could travel freely for the first time. The evidence for this story is written all across the cosmos. We see it in the fact that galaxies are moving away from us in every direction, a discovery made by Edwin Hubble that first hinted at an expanding universe. The farther away a galaxy is, the faster it recedes. If you run the cosmic movie in reverse, everything comes back together to that single point in the distant past. We also see the afterglow of that initial creation. It's a faint, pervasive microwave radiation that fills all of space, known as the cosmic microwave background. This is the oldest light in the universe, the remnant heat from the fires of the Big Bang, now cooled to just a few degrees above absolute zero. This model is a monumental achievement of human intellect. The Big Bang Theory is magnificent, but it has a frustrating limit. It describes what happened from the first tiny fraction of a second onward with incredible precision, but it stops dead at time zero. It tells us how the universe evolved, but not why it came to be in the first place. What was there before the Big Bang? What ignited that initial hot, dense state? The theory itself is silent. The laws of physics as we know them, including Einstein's theory of general relativity, break down at the singularity. All our mathematics returns answers of infinity, which is the universe's way of telling us we're missing a piece of the puzzle. This is perhaps the biggest question in all of science. To say nothing was before the Big Bang is unsatisfying. How can a universe of such immense complexity with its intricate laws and structures emerge from absolute nothingness? It feels like a violation of our deepest intuitions about cause and effect. Some theories in quantum mechanics suggest that a universe could indeed pop into existence from a quantum fluctuation in a void, a kind of ultimate free lunch. But this idea, while mathematically plausible, is difficult to test and leaves us with a sense of cosmic vertigo. It feels like the story is missing its first chapter. Think of it like this. You find a book and it starts on page 1 with the sentence, "And so, the expansion began." You can read the entire book and understand the whole story that follows, but you'll always be haunted by the missing preface. What happened that led to that first sentence? Who, or what set the stage? The Big Bang singularity presents us with this exact problem. It's a boundary not just in time, but in our knowledge. It's a wall, and for a long time, we've had no idea how to even begin to peek over it. We've been staring at the effect without a clue as to the cause. So, scientists, in their endless curiosity, started looking for other possibilities. They began to wonder if the Big Bang wasn't a beginning from nothing, but rather a transition from something else. This is a mind-bending, spectacular idea, but is it science or is it just science fiction? For an idea to be scientific, it must be testable. It must make predictions that we can, at least in principle, verify through observation or experiment. The black hole bounce theory is still highly speculative, but physicists are not just waving their hands. They are performing complex calculations based on theories like loop quantum gravity to see if the mathematics holds up. These calculations are beginning to show that a bounce is a genuine possibility, a natural outcome of how quantum spacetime should behave under extreme pressure. More excitingly, the theory might leave subtle, observable fingerprints on our own universe. If our cosmos was born from a bounce, its initial conditions might be slightly different from those of a universe born from a classical singularity. Some physicists have suggested that the bounce could have created specific patterns or anomalies in the cosmic microwave background radiation, the ancient afterglow of the Big Bang. These might appear as strange cold spots, large-scale alignments, specific types of fluctuations that wouldn't be predicted by the standard Big Bang model alone. Scientists are meticulously scanning the data from probes like the Planck satellite, which has mapped the cosmic microwave background in exquisite detail. Searches use magnified views to look for tiny anomalies. It's like being a cosmic detective, looking for a single, faint fingerprint left at the scene of the crime, the birth of the universe. So far, no definitive smoking gun has been found. The signals, if they exist, are likely to be incredibly faint and difficult to distinguish from random noise. But the search is on, and every new cosmological survey gives us a clearer picture to examine. Another avenue of investigation is through gravitational waves, ripples in the fabric of space-time itself. The bounce would have been an incredibly violent event, and it might have produced a unique gravitational wave signature. Our current gravitational wave detectors, like LIGO, are designed to detect waves from merging black holes and neutron stars in our own cosmic neighborhood. But future, more sensitive detectors might be able to pick up a primordial gravitational wave background, a faint hum from the universe's birth. If this theory is true, its implications are staggering, expanding our vision of reality to a scale that dwarfs even our own vast universe. Think about it. Our cosmos is filled with black holes. We see them at the centers of nearly every galaxy, including our own Milky Way. We see them formed from the deaths of massive stars. If every single one of those black holes contains the seed of a new universe, then the cosmos is engaged in a perpetual cycle of self-reproduction. Our universe isn't just one of a kind, it's a branch on an infinitely vast and complex cosmic tree. This leads us to the concept of the multiverse, not the parallel worlds multiverse from fiction, but a physical, nested multiverse. Our universe exists inside a black hole in a parent universe. That parent might exist inside an even larger black hole, a grandparent universe, and so on, perhaps infinitely. All the black holes in our universe could be giving birth to countless baby universes right now, each with its own Big Bang, its own expansion, its own potential for stars, planets, life. It's a cosmic fractal repeating creation at different scales. This vision of a fecund universe changes everything. The laws of physics might not be identical in every new universe. Each bounce could slightly alter fundamental constants. In some universes, gravity might be weaker, In others, the electron's charge might differ. Most of these universes would likely be sterile. Their physics might not allow stable atoms, or stars, or galaxies. They'd be born and then quickly fade or collapse. But with infinite births, some, like ours, are statistically likely to have the right laws for complexity and life. This offers a solution to the fine-tuning problem. Why are our laws so perfect for life? Change a constant a tiny bit and our cosmos wouldn't exist. The black hole bounce multiverse answers this. We live in one universe where conditions happen to be right. We couldn't exist to ask in the others. We won the cosmic lottery. Not because it was rigged, but because there are infinite tickets.